Okay, so remember that we are using uniform likelihood, but actually, uniform prior, sorry. We are using uniform prior for our hyperparameters, but actually you can use a whole lot of different ways to define your prior. So here's just give you some example. So we using uniform prior before, but now if you have a good understanding, you can use normal distribution, you can use log normal distribution, you can use student t-distribution to have a longer tail comparing to normal, but you can have a kind of gamma distribution, inverse gamma distribution if you think about the parameter can concentrate it in a small area, but have a really longer tail. So you have a lot of options. So which we will cover a bit in our software, how to do that. And okay, so something new in our software, maybe you haven't heard that before, is instead of sampling the posterior distribution using Markov chain Monte Carlo, there's a different way to get the posterior distribution, what we call the variational base. So instead of drawing samples using Markov chain Monte Carlos, you can think about this blue curve here is our true posterior distribution. Our goal is now to use this QZ, which is a parametric distribution. Maybe parametric distribution basically means we know the equation, how to describe this distribution. This QZ here maybe is a normal distribution. So we want to use this QZ to approximate this true posterior distribution PZX as much as possible. So in this case, our goal is transformed from sampling posterior samples to optimize the parameter for this QZ. So this QZ can use as approximation for this true posterior distribution. So this is what we call the variational base. Why we try to use variational base is that it's computationally much cheaper. So if you think about Markov chain Monte Carlo, sometimes you need several hours, several days to do some sampling if you use complicated process level model. But this QZ is computationally much cheaper, and it kind of embedded pretty well with modern stochastic optimization techniques, which you use for most of the AI technique now.